VCC 10 volts. RB 1 meg. RC 330. Voltage at the red LED 2 volts. Q1 HFE 175. Q2 HFE 225. So that's my parameters. Let's analyze this circuit. Let's see what's going to happen. Okay, first thing I do, calculate IB. But before I calculate IB, I'm going to find HFE total, the gain total, beta total. How do I find beta total in a Darlington? Beta 1 times beta 2. Okay? So that's how Darlington pair works. Beta 1 is 175. Beta 2 is 225. How much? 39,375. That's the current gain. That's saying that a current at IB of the Darlington of a small amount gets magnified by about 40,000. VBE at Q1. VBE at Q1, right here. Base emitter. PN junction. How much? 0.7. VBE at Q2. Base here, emitter here. How much? 0.7. So therefore, B base to emitter total. Total is from the base of the first to the emitter of the second. So that is 0.7 plus 0.7. Okay? 0.7 here. If I measure in my circuit the voltage from base to emitter, it'll be 1.4. 0.7 and 0.7. Okay, so that's VBE. With this value, I can now find IB. This current here. IB is the current flowing in RB, so it is V over R, which is the voltage CC minus the voltage from here to ground, which is 2 times VBE, which is VBE total, divided by RB. Okay, so it's 2 times VBE. So that's 10 minus 1.4 divided by 1 meg. .6 microamps. Okay, so that's 8.6 microamps. That's here. That 8.6 microamps is going to be amplified on the collector side by 39,375. So that's IC at Q2. So that's IB at Q1 times beta total, which is 8.6 microamps times 39,375. Which is how much? 339 milliamps. if I was to break this circuit here and measure the current in a real circuit, if you break the circuit and measure the current, it's not going to read 339 milliamps. Let's see what it's going to read. Let's see what it's going to read. Watch. Let me explain what's happening. So, here's your little tap. You opened it a little bit, it caused a lot of current to flow in this circuit. When you have a lot of current flowing in the circuit, this is what's happening. A lot of current in a transistor circuit, and we know that the load line is the operating point of a transistor circuit. The maximum amount of current that can flow in a transistor is what? Right? And at the maximum current, how much is the value of VCE?
0.
0. So that's what we're saying. That in this circuit, I'm going to draw a circuit on the right side here where you've got figure 2. Draw this. VCC, show your LED. Okay, on the right side, everybody, draw this circuit. Resistor, and where you've got transistor Q2, do this. Draw this.